Hi, I hope that you're having great time at SQL Bits Online. My name is Mladen. I'm a program manager on Azure SQL team, focusing on Azure SQL Managed Instance. I'm glad to be here with you today and talk about Managed Instance. We are starting with two short intro topics, when to choose and what to expect with SQL MI, spending only a few minutes there to establish a baseline, before we move to the recent and upcoming additions to the service, the value they bring, and interesting scenarios they unlock. So let's start by giving rough coordinates of the service we are talking about within the Azure Service Portfolio services. I won't go into comparison of services here. There is a dedicated session on Saturday. My colleague Anna Hoffman will talk much more about Azure SQL and what to use when. In all overviews of Azure SQL, you will see Managed Instance positioned in the middle between SQL on VM and SQL Database. On one side, with its high compatibility with SQL Server Engine, it's similar to SQL on VM. On the other side, it shares the platform with SQL Database, hence they share majority of the PaaS capabilities. That's why Managed Instance is best positioned for the modernization of the existing solutions. If you are to attach some keywords to these services, for SQL MI it would be compatibility and modernization, for VM full control and lift and shift migration, and for SQL DB it would be innovation and flexibility. Let's now transpose these metrics and start from the requirements, meaning capabilities and level of control, which will then lead us to a service of choice. In terms of capabilities, there is a limited set of requirements that are tightly coupled with having a full control. So if you need OS access, or if you really need to stay on the previous versions of SQL Server, perhaps because of third-party software provider requirements, if you want to choose which upgrades and which patches to apply, or if you need to collocate your application with your database or any other services like SSRS, SSAS, SSIS, then most probably SQL on VM is your service, and you will still get benefits like automatic updates and security patches. Now, if you don't have any of these specific requirements, you can continue to this simplified decision tree, and PaaS, service managed, starts being assumed. Now, if you need any of instance scoped features listed, your workload is a good candidate for SQL Managed Instance. Otherwise, you can enjoy benefits of SQL Database and as the most flexible offer. But it's not always clear to people what to expect with transition to service managed model, in terms of split of work, or even more in terms of level of control available. That leads us to the next topic. We will go through several standard sets of tasks of a team managing database assets and see what tasks could be unloaded onto SQL MI service and whether control stays in team's hands. We are starting from the service deployment aspect, and we will use classification into activities provided by the system and activities staying team's responsibility. So with service deployment, you don't have to care about hardware allocation, about deployment of a specific service's binaries. That's provided by the service. On the other hand, you keep control about the service tier selection, about the size of the instance, changing the sizes of the instances according to your needs and to your workload. And then, of course, you can schedule all of these operations. When it comes to updating the system, both OS level and SQL Server level updates, service updates and patches are done by the platform. So the burden of these updates is offloaded from you. On the other hand, anything that really affects the behavior of your application and of your system is still under your control, meaning updates of database schema and any compatibility level changes. For connectivity and network security, thanks to the service-aided subnet configuration, our platform guarantees that minimum set of requirements for management traffic to your virtual cluster and your resources within the virtual cluster will be maintained. And on the other hand, for the data traffic, you have a full freedom of filtering and routing that traffic and optionally configuring express route. Certificates. So for transparent data encryption, for transport layer security, for exchange of the certificates between managed instances within failover group, and for the AAD authentication, the entire burden is on the service here. On the other hand, you can, if you want, change keys being used for the encryption of your data with transparent data encryption and switch to the BYOK solution or customer managed keys. Now we are coming to a very important aspect of high availability and disaster recovery. So what you are getting out of the box with managed instance is built-in HA configuration. Also, if you opt in for geo-replication, failover groups will take care of a geo-replication, and you can even rely on the auto failovers. Now, you know that in the on-premises world, to establish such an environment and configuration in SQL Server, it might take days or even weeks. So this is really a great benefit. On the other hand, you still stay in charge for establishing cross-region connectivity for geo-replication and picking the right solution that fits your needs there. You can decide about the size of the geosecondary instance, and you can do manual failovers both for the local HA and for the geo configuration. When it comes to the database backups and backup management, platform provides geo-replicated automatic backups, not just full but also differential and lock backups, so that you can do point-in-time restore and geo-restore manually whenever you need it. You can also do a manual backups unless you are using a service managed TD. Single sign-on authentication through the AAD is also offered out of the box. On the other hand, you keep control on the synchronization of the accounts from your Active Directory and AAD through the AD Connect. You can still use AD Federation service, and you are controlling client drivers that you're going to use. On the monitoring aspect, platform takes care about collecting and streaming all the health metrics and the performance metrics. On the other side, you keep the freedom of choosing your monitoring solution or configuring some of the offered monitoring solutions available in Azure and configuring Azure alerts in the rich environment offered in Azure. So as you can see, in all of these aspects, there is a good balance between offloading burden of the operational work from you and still retaining the control over all of these operations. Before we close the topic of balance between the provided services and level of control and flexibility retained, let me put more light on a related concern that we sometimes hear. It's about native init integration and whether it limits the implementation options for the rest of the solution. People say, hey, I don't really need VNet for all of my databases. Can I opt out? The answer is no, but it doesn't mean that integration options are narrowed in any way. We basically built a solution highly secure by default, where you still stay in control of how wide you want to open it to the rest of your Azure and on-prem assets, other cloud services, or your end users after all. And not just that. At the same time, you have a full freedom of choice where and how you want to host the rest of the solution. So you are starting with a SQL MI VNet and with managed instances within MI subnet. So the first logical choice would be to place your application within the same VNet, just in another subnet, and you still have a choice of way to host it, be it app service or IaaS hosted options like VMSS, VM, and so on. Or you can have a separate application VNet, again with the different hosting options, and then leverage some of the peering or VPN channels to connect your application VNet with the MI. If you have a web application, you can use VNet integration option, either directly or through the peering channel. For your on-premise assets, you can still use ExpressRoute or VPN gateway connection and connect to the MI. Now, for the Power Tools family like Power Apps, Power BI, Power Automate, you can either choose public endpoint and still control the access rights with the NSG firewall rules, or you can use a data gateway and basically even avoid opening public endpoint if that's concern. Now, on top of all of this, we are now also adding more options for better integration between the applications within the VNets, including a private link and the global peering. Now, obviously, your choice is not narrowed at all just because managed instance is secured by default by being integrated into VNet. Let's jump to the updates, what's been released recently and what's coming soon. There are so many things to show and mention that I decided to split this overview into multiple areas or value streams. So we are starting with the SQL Server compatibility and seamless migration. Here is the vertical timeline divided into three parts. Past, that's available section, so that's basically everything that's been introduced since beginning of this calendar year. Now, announcing part, it's everything that's been announced last week during the Ignite or what we are announcing this week or next week. And then coming soon section covers the upcoming things that are coming in the following several months. So let's start. Okay, so there are two AAD-related improvements that landed early this year. So basically, AAD server principals or AAD logins were GA'd, and also we introduced support for Windows user migration to the AAD accounts. Then what's been just announced at Ignite last week was machine learning services. So with machine learning services in managed instance, you can run R and Python scripts to do either data preparation or any general data processing. Or you can train machine learning models in the database directly, or you can deploy your models and scripts into production using in form of stored procedures. Another thing that's coming is support for hosting SSRS catalog databases, namely SQL Server reporting services previously couldn't host their catalog databases, two of their catalog databases on Azure SQL Managed Instance. Now, SQL Server 2019 reporting services added native support for managed instance. However, for the older versions of SSRS, which are still in use, perhaps you cannot migrate to the newer version of SSRS. If you're still using these older versions and want to migrate your data tier to managed instance, you can do that now by changing a couple of configuration options in managed instance and then installing older version of SSRS and pointing it to managed instance as a repository for the catalog databases. Now, what's coming really soon is support for distributed transactions. So this is a great example of a feature that at the same time unblocks migration of the existing solutions, but also unlocks possibilities for their modernization and for building new modern solutions. Now, if you ask yourself what does modern mean these days, please watch a session that Connor Cunningham has here on SQL Beats. He's covering this into many details. So I will dive deeper into distributed transactions in a couple of moments. Let me just finish coming soon part. So log replay API is based on the log shipping feature from the SQL Server on premises. It's been exposed to the database migration service for a long period. However, we are now exposing log replay API also to you so that you can leverage it for minimal downtime migrations without using database migration services if that is your use case. And finally, later this year, we are enriching existing service broker feature in SQL Managed Instance. So far, you could use service broker to exchange messages within a database or between the databases on the same managed instance. However, now we will enable service endpoints for service broker, and you will be able to also exchange messages across the instances. Let's see what distributed transactions can do in SQL Managed Instance. Let's imagine that we have distributed solution with the instances scattered across Azure regions, so that each instance contains a subset of data. It could be sharded horizontally partitioned data, it could be vertically partitioned data. In any case, we do want to touch the data across all of these databases in a transactionally consistent way. Now, there is an application that can issue begin distributed transaction T-SQL command, or can use .NET class transaction scope to initiate this distributed transaction. One of the databases participating in this distributed transaction will be declared as a transaction coordinator, which means that instance hosting this coordinator database must be able to communicate with the other instances participating in the distributed transaction. This also means that there must be a trust established between those instances. This leads us to the newly established entity, so-called server trust groups. This is the abstraction for the establishing trust between the instances. So as you can see, distributed transactions are a great addition to managed instances' main value props of compatibility and modernization. During the preview, there are some limitations. So participants in the distributed transactions could be only managed instances, so no on-prem SQL server. And also on the application level, .NET is the only supported technology in addition to the T-SQL. Let's now talk about improvements in the business continuity and disaster recovery area. So earlier this year, we introduced support for GeoRestore as a cheap and economically efficient disaster recovery option for solutions with some tolerance to the recovery time objective, or RTO. Also, we added support for point-in-time restore for deleted databases that wasn't available previously. Accelerated database recovery was a huge thing. Like it's now on by default on the entire Azure SQL, including managed instance. So with advanced database recovery, we basically enabled fast and consistent database recovery. Now, long-running transactions do not impact the overall recovery time anymore, which enables us fast and consistent database recovery, irrespective of the number of active transactions or their sizes. Then, second gain is instantaneous transaction rollback. So now, irrespective of the time that the transaction has been active or the number of updates that it has performed, it will now roll back almost instantaneously, thanks to the underlying persistent version store that ADR leverages. And then the third thing is aggressive log truncation. So basically, with the ADR, transaction log is being aggressively truncated even in the presence of long active transactions, which now additionally prevents log from growing out of the control. Finally, last week at Ignite, we announced support for global VNet peering in Azure SQL Managed Instance. With global virtual network peering, you can now seamlessly connect virtual networks in different Azure regions. So let's take a closer look to the global VNet peering support. So what we have here is one GeoDR solution using failover groups between two regions. And basically, in order for this geo-replication to work, for this replication traffic to flow, you have to establish some kind of communication channel between those two regions and virtual networks. So in the past, you would typically use VPN gateways. However, in certain network topologies, VPN gateways cannot be used. Example would be some of the hub-spoke architectures. Then alternative solution was also using your express route and basically routing this replication traffic all the way through your private network. Now that would eat part of the bandwidth that you have with your express route, and at the same time you would be exposed to the risk of unintentionally cutting this traffic on some of your on-prem firewall devices, for example. Now with the global VNet peering, you are getting really like ease of setup, a low latency solution, and with a throughput that is not limited at all with the global VNet peering itself. So basically, there are no additional restrictions on bandwidth within the global peering, aside from what's the bandwidth that's already allowed for the instance. Moving to the security and compliance area. So at the beginning of the year, we enforced Transport Layer Security Protocol 1.2. It's now on both for the inbound and outbound traffic. So if you are working on some new solution that requires communication with the on-prem previous versions of the SQL Server, bear in mind that you will have to install some of the cumulative updates for the versions of the SQL Server before 2016 for this TLS 1.2 to work with the previous versions of SQL Server. We also first introduced and then also enforced service-aided subnet configuration as a way for system to keep up to date and in compliance with the requirements of Azure SQL Managed Instance service, your network settings, including network security groups and your user-defined routes. So basically, system would make sure that your UDRs and NSGs are in compliance and that you will not break some of the management traffic required for the normal functioning of your managed instance. Now, all the rules added by service-aided subnet configuration are transparent to you, so you can see all of them. They have a prefix in the name so that you can see that those rules have been added by the system. Also, on the compliance perspective, we added support for LTR, long-term backup retention. A backup retention period is up to 10 years with configurable frequency of backups being taken and kept. After that, we also introduced support for virtual network service endpoints. So if you plan to integrate with your storage or with your Azure Key Vault, for example, in customer-managed transparent data encryption solutions, you can now use service endpoints to establish a more secure communication than before. What we announced a few weeks back was support for additional backup file redundancy options. So up to now, only geo-redundant storage option was available for managed instance. So with these new two options, locally redundant storage and zone redundant storage, you now have a freedom to choose. And basically, with the local redundant storage, you have low-cost solutions for your non-prod dev test environments where you can easily restore data from some other systems. So these systems, if they are not like single source of truth, you can rely on the local redundant storage. There are still 3 redundant local copies of your storage within the same region with LRS. Zone redundant storage is available in a subset of regions with availability zones. And with the zone redundant storage, you can meet the requirements of data residency. So imagine scenarios and compliance requirements where your data cannot leave a region. So now with zone redundant storage, you still have redundancy and high resiliency to outages on the level of data center because data is being replicated to all 3 availability zones within the region, all 3 data centers. And then globally redundant storage stays still a way to go for the most critical solutions where you really have to rely on availability of those backups. What's coming soon is support for service endpoint policies for storage. Remember that I mentioned previously that we added support for service endpoints for storage. Now with the service endpoint policies, basically we are allowing even stricter rules so that you can prevent some types of the data exfiltration scenarios and restrict access from managed instance to a specific to a specific storage account, to the specific storage. And then next important thing in the security and compliance area that is coming soon is support for the private link. Let's talk more about the private link and see what's so special about private link support in managed instance. As we know, managed instance is always injected into a virtual network, and it gets an IP address from the IP address space range of the underlying virtual network. This IP address can change from time to time. Now imagine that we have an application with its own network and its own IP address range. Now if we have a private endpoint within this network with IP address assigned from the local IP address range and then pointing to a specific MI, now we have two benefits. First one, from the perspective of application, we now have fixed private IP address of this managed instance. But also this now also enables more granular traffic control, because now application A has access only to managed instance 1. Previously, if we wanted to allow application A to access managed instance 1, we would have to open traffic on the level of the subnet. So at the same time, we would also allow application to access managed instance 2 on the networking level. There are more advantages. So imagine that we have two more applications, and this is like distributed network architecture with different tenants, different Azure tenants. So application B might be your supplier on some other region in Azure, and then your application C might be your end user. Also, you need to access some of your instances. So now your if within your application B, your supplier's application, there is also a private endpoint with its own IP address, it can also now access your managed instance 1. On the other hand, your end user can only access your managed instance 2 if there is a private endpoint within its own network. So this distributed network architecture now works across regions, across Azure subscriptions, and even across Azure tenants. No limitations to that regard. Let's talk about improvements in the performance, scalability, and cost optimization area. So you already noticed that I mentioned cost-saving aspects of some of the previously mentioned features. But now here we have a couple of features that fall directly to this category. So recently we improved a backup in terms of the compression, but also in terms of the retention period that can now be less than 7 days in order for you to manage the cost of your solutions in situations where backup retention is not critical. Also, there was a lot of improvements in the performance space, primarily in the log rate area. So let's see what are those performance improvements. There are many common scenarios where log throughput or log rate is a limiting factor for the overall performance of the system. Some of the examples would be heavy data ingestion or index rebuild. So that's why we focused on increasing log rate, both in the general purpose and business critical service tier. Now there is a lot of figures on this slide, but please bear with me. So per instance limit for general purpose service tier starts as a linear function of number of vCores, like it's 3 megabytes per second per vCore. Now on the other hand, there was a cap on the instance level of 22 megabytes per second, which means that even a small 8 vCore general purpose instance could not use all of the log rate that would belong to it based on the number of vCores. Now we were able to increase this log rate almost 6 times on the instance level, up to 120 megabytes. However, there are also per database limits. Those used to be 22 megabytes per second in all cases for general purpose case. Now we were able also to dramatically increase these log rates on the database level. So for the largest file sizes bigger than 2 terabytes, it's now as much as 65 megabytes per second, as you can see on the chart. Now, if we take a look at the test results for the general purpose service tier, we can see multifold improvements. For example, TPCC shows 4 times better transaction throughput. Scans are twice better. Data ingestion shows 2 to 3 times improvement in terms of the data ingestion rate. TPCH also shows lower execution times for 23%. We also improved the log rate for the business critical service tier. We doubled its cap from 48 megabytes per second to 96 megabytes per second. Let's now see these performance improvements in action on the case of index rebuild. We are comparing performance of the index rebuild operation on two identical tables in two identical databases hosted on two instances, where the only difference between the instances is the fact that on the managed instance with suffix 01, these log rate improvements are turned on, while on this instance, those improvements are not turned on yet. Okay, so let me first connect to the instance without the improvements. It's number 2. Change the database and run the script. So as you can see, the script is pretty basic. We are taking as a starting point log size in megabytes before we run the rebuild operation. Now we run this operation, and at the end we are taking new log size value in megabytes and then just calculating average log rate. Now this operation will take around 30 seconds on this instance. Yeah, as we can see, it took 28 seconds and average log throughput was 24, which is in line with the previous maximum log rate as described. Okay, let's now connect to the instance with the log rate improvements turned on. And run the same script and see what's going to happen. This time we expect much higher log rate. So it takes only 9 seconds and average log throughput is calculated as 75 megabytes per second. So it's more than 3 times higher than on the instance number 2. Back to the topic of cost optimization. So I already mentioned that we introduced a couple of optimizations in the automatic backups. So first thing is that we added more fine-grained tuning for the point-in-time restore backup retention period. So for the active databases, previously you could choose anywhere between 7 and 35 days of the retention period. However, there are systems where you are totally fine with a shorter period of retention of backups. So now we allowed to go down all the way down to 1 day for the backup retention period for the active databases. And for the deleted databases, you can even set 0 days of backup retention. Now, order of steps here would be first to delete database and then to specify 0 days of retention for this specific deleted databases. At the same time, we significantly improved compression of the backups, specifically for the TDE encrypted backups. You know that transparent data encryption is on by default in Azure SQL and SQL Database and SQL Managed Instance. So this improved compression basically applies almost to any backup you might have in a SQL Managed Instance. Now, we already covered additional backup storage options in the compliance section. So I mentioned geo-redundant storage is now not the only option. Now you have zone redundant and locally redundant storage options. This is now also interesting from the cost saving perspective and cost optimization perspective, because locally redundant and zone redundant storage costs less than geo-redundant storage that was default so far. Now to the topic of improvements in the area of monitoring and manageability. Back in July, GA of SQL Management Pack for SQL MI has been announced. So System Center Operations Manager now has a management pack specific for Azure SQL Managed Instance. built based on the management pack for SQL Server with a known and familiar environment. I will talk more about SCOM management pack in a minute. Beside that, back in August, we introduced support for user-initiated manual failovers that you can now issue. So it falls into manageability area because you can now solve some of the tempDB growth issues by issuing failover command. But also bear in mind that you can use these user-initiated failovers also for early testing of your application resiliency to the failovers, which are unavoidable in the cloud space. Last week, we introduced support for AAD directory readers role assignment for managed instance. This is a huge relief, especially for large enterprises with very strict separation of duty policies. I will talk more about that also in a moment. In terms of monitoring and alerting, we introduced support for additional two features very recently on the portal. So you can now query log analytics directly from the portal, and also you can manage your alerts based on the metrics directly from the portal. What's coming soon in the following months is integration of managed instance with resource health on the instance level. So basically, specific databases within a managed instance even today are integrated with resource health. However, any health signals on the level of instance, specific to the instance level, are not available in resource health yet. Once this integration is in place, you will be also able to set up resource health alerts and get notified on any types of events that you are interested in. As I mentioned, AAD directory readers role assignment, which is preview feature, is a huge relief for some of our customers. So basically, if you ever wanted to integrate your managed instance with Azure Active Directory, you probably see this message on the portal that managed instance needs permissions to access AAD, and that you have to grant read permissions to your managed instance, more precisely to its managed identity. So this was a step that previously could be performed only by global admins for your AAD tenant or privileged role admins. And that action has to be done for each and every instance. Now imagine person creating instances every day and then like pinging their global admins to add this instance, to basically grant read permissions to each and every of these managed instances. Now, based on the new preview feature of role assignment to the AAD groups, now we can engage group admin only once to perform a couple of steps, and then with each next instance, another person can do the entire job. So basically what global admin or privileged role admin has to do is to create new Azure AD group and to assign directory readers role to this group. In the next step, any persons creating those instances can be assigned as a group owners to the newly created group. It could be any Azure AD user without any specific role attached to it. Once this is done, and after this propagates after a couple of minutes, this propagates to the Azure Graph, owners of this group, basically people that are actually creating these instances, can on their own now add this managed identity of their instances to the previously created group. This way, a managed instance will be able to read AAD in the future when checking access rights for a specific AAD account. Huge relief, really, for some of the scenarios. I also promised to talk more about SCOM and about specific scenario of monitoring hybrid environments using SCOM. So now that SCOM family of management packs for SQL is richer for management pack for MI, there is ability to monitor your entire hybrid SQL environments, including SQL Server on-prem, SQL Server on virtual machines in Azure, but also SQL Database and MI. Both of them have their own management packs now. So SCOM is now the most comprehensive monitoring solution for MI. It offers automatic discovery of Azure SQL resources, it has updated dashboards, and it has monitoring for some of the specific features like failover groups. There is a separate SQL Bits session related to failover groups where I'm doing a deep dive to the failover groups, and there you can see a demo of SQL Management Pack and specific features within the Management Pack pertaining to the failover groups. Okay, what about service deployment and patching aspects? So it might be critical for integration with your CI and CD pipelines. So we did a couple of things over the last year here. We enabled instant storage scaling for the general purpose service tier without any downtime or failover. Also, online hardware generation upgrade is now possible. So you've probably heard that Gen 4 hardware is now on the exit path from the Azure SQL. And this way we are enabling you to migrate to the newer hardware generations, not just from Gen 4 to Gen 5, but also in the future. Hardware generation changes without any downtime with a simple failover. Last week at Ignite, we also announced enhanced instance management experience, meaning improved transparency of the instance management operations, like creation and resizes of the instances. Let me cover it more into the detail in a moment. Before that, I would just like to announce also that what's coming very soon is support for maintenance window capability. So basically, we will start with a couple of predefined windows that you can choose between so that any impactful upgrade operations on your virtual cluster happen only during these maintenance windows. That way you will definitely have a better predictability of the failovers on your environment. More about the enhanced instance management experience. So basically there are two parts of this improvement. Existing CRUD API now has a new version. This new version now exposes provisioning state property, and new managed instance is basically visible with its name from the start of provisioning process. As you can see on the picture, this third instance has creating state. The other part is so-called operations API that is newly introduced. This new API is used for retrieving status of create update operations for managed instances and can be used in automation scripts. So based on the current operation step, you can kick off another operation or process. So calls to the new operations API contain both operation parameters, old and new, and also it contains current step, total number of steps, and the details of each step, as you can see also on the screen. Additionally, Operations API enables capability for canceling the operations, and it is also fully supported through the portal, CLI, and PowerShell. That would be all the news for this time. We are working on much more, so please stay tuned. Follow us at Azure SQL. Subscribe to Microsoft Tech Community for Azure SQL. Check our online documentation and try our Azure SQL workshop. I'm really glad that you joined. Have a great day, have a great rest of the conference, and stay safe. Thank you.